Okay. Paste. Okay. Good morning, Carly. How you doing? Let's see. Hey, Carly, did you get my my email about your recommendation? Check, check. All right. Let's see if anyone's here. All right, we'll wait a few minutes, guys, while we're waiting for everyone to file in if they're going to come. But the first thing I want to do is go over any questions you have on the 6.1 quiz that I posted the key to yesterday, and then we'll go over any questions you have on the 6.2 quiz, and go over any questions you have for that, and and then we'll go over any other random questions. And then we could also go over anyone who did the concept check 2. We can go over any questions, and even if you didn't complete it, we could open that up and go over any questions on the Unit 6 concept check 2 to see if you have any questions about that. Yeah, and then I'll explain to you what I want you to do from here out. I've already posted it, but we'll go over that stuff too. Okay. So you got it, Carly. So just if you email me that information, Carly, I'll just drop it by your mailbox because I'll be over to see my in-laws later today. So we'll be right on Side and Stricker. Okay. Okay. All right. All right. So again, we'll wait a little bit longer, just to see. We got, I think, 4 people in here now. And again, if you can't chat, then send me an email question. Okay. Okay. All right. All right, guys, so first thing, let's open it up to questions on the 6.1 quiz. Again, I posted the key And 8th period and 1st period students did take this quiz, but 2nd period did not. So hopefully you had a chance to look it over if you're in 2nd period. And let me know if you have any questions on any of the problems here. I think it's pretty straightforward, and you might just, the key mistakes that were made on this quiz was using this value as the delta S of the reaction value, even though that's the entropy of just the C2H6. The entropy for the reaction, the delta S for the reaction, is this value here. So when you calculated your delta G, you had to use this value for your delta S, not this value here. And you also had to calculate your delta H first before you could use that equation to calculate delta G. And then I guess the other most common mistake was when you're using this equation to solve for K, a lot of people plugged in delta G in kilojoules instead of joules, and it's got to be in joules when you use this equation, because again the 8.314 R constant is also joules. So if you plugged in kilojoules, it didn't work out for you. And then also make sure your answers agree. A lot of people did get a negative delta G, and even if they got the wrong value, if they got a negative delta G for this part, then they still got the answer correct for here. They knew it was thermodynamically favored. And I did read down, so if you put a positive delta G here and you said the reaction wasn't spontaneous or wasn't thermodynamically favored for part C, then you got credit for that, even though it should have been a negative delta G. And then down here, again, if you have a negative delta G, you should get a KEQ that's greater than 1. If you have a positive delta G, then you should get a KEQ that's less than 1. So a lot of people did get a negative delta G, and then when they solved for K, they got a value that was less than 1. So that should have, made you think something might have gone wrong in your calculation. Okay. So again, are there any questions? I'll check my email if you're sending questions, but do you have any questions on this quiz? If yes, ask it in the chat or send me an email and we'll go over it. Okay. And if not, we'll move on to 6.2. But are there any questions for this quiz at all? And then in, I guess, part E, you had to use, bonds broken minus bonds formed. So that's reactants minus products that time. And your unknown bond was the C triple bond C, so this bond right here. And so you had to use all those bond energies. The C double bond C is kind of a distractor. That's there just in case you don't know your organic structures enough to know if you need to use that. And it's also there as a reference. You're getting C triple bond C. It should be strong. It should be a higher bond energy than 611. So like if you solved for the C triple bond C and got a value that was less than 611, then again something was wrong with your calculation. So when you do it, it comes out to be close to 820 kilojoules per mole for the bond energy. Okay. Are there any questions with this quiz? Going once, going twice? Other people might show up later, but we can come back to it. All right. Feel free to check into the chat and just say, hey, too. Check. We got 8 viewers right now, so I'll keep going as long as we got some people watching. Let's see. Okay. All right, I'll open it up to questions about the 6.2 quiz. All right. So hopefully you went through the 6.2 quiz on your own and then maybe checked the key yesterday. Let me know if you have any questions on the 6.2 quiz, okay, on the electro stuff. All right. Any questions right off the bat or, okay. Okay, so 1C on 6.2, all right? So, okay, so this is using, you can either use the Nernst equation. So when you're asked, okay, so what you have to remember is that standard cell potential, which is the E with the degree sign, so E naught, okay, that's the standard potential. And that's what the potential is going to be expected to be if you build your galvanic cell, so you build this battery at standard conditions. Now, standard conditions for electrochemistry is 298 Kelvin, so 25 degrees Celsius, same as thermodynamics, and it's 1 molar for your concentrations, 1 mole per liter for your concentrations of your ions in solution. So for like this battery, I need to start for the voltage to be the standard voltage, which was 1.14 volts. I have to start with 1 molar silver at the cathode. I have to have 1 mole per liter of silver ions at the cathode, and I have to have 1 molar here of chromium ions at the anode. Okay, so now what we're doing is here, notice that we're making the battery, but instead of being at standard conditions, we're at 2 molar, right? We're at 2 molar chromium. They didn't say we changed the silver, so we're assuming the silver is still 1 molar concentration, but still, if one of our concentrations is not 1 molar, then we're not at standard conditions. So that's when you could invoke the Nernst equation, okay? Now, I'm gonna tell you how to not use the Nernst equation to answer this question, because we didn't really have to calculate the new potential to compare it to the standard. Really, we could use Le Chatelier's principle to compare it to the standard potential, or if we just have an idea, we can say the Nernst equation. We don't even have to write it down. We can just say Nernst equation, and then say because Q is greater than 1, the potential is going to be less than the standard cell potential, okay? But anyway, here's the Nernst equation. So if you want to use the Nernst equation, you got to memorize it because you don't get it on your formula sheet, okay? It says the new potential, so the potential that's not at standard conditions, so E without the degree sign, so the potential not at standard conditions is equal to the standard cell potential, which we calculated before, 1.14 volts, minus RT/NF, so it's 8.314 for our R value. Temperature's 298 because we didn't change the temperature. We're still assuming regular conditions except for 2 molar chromium instead of 1 molar chromium. NF, so N is moles of electrons being transferred, and we had to realize that in the balanced redox reaction, it's 2 moles of electrons being transferred, okay? So N is 2 in this case. And then F is Faraday's constant, okay? Now, Q, what is Q? Q is equal to the equilibrium expression. Well, okay, so if we did the equilibrium expression for this reaction, this is our overall reaction here, the equilibrium expression, we would not include the solid silver on this side, and we would not include the solid chromium on this side because we don't include solids in the expression. So the equilibrium expression is equal to the concentration of chromium divided by the concentration of silver squared. Okay, so, and I have that on the key here. This is what Q is equal to. So if you plug in 2 for the concentration of chromium, and you plug in 1 squared for the concentration squared for silver, you get Q is equal to 2. So that's why I have the natural log of Q over here in my Nernst equation, okay? So when you do that, you get a positive number, okay? And when you subtract a positive number from a number, then the number gets smaller, right? Okay, so you do that math, the number is a little bit smaller. So what does that mean? It means the new potential or the expected potential for this battery, if we made the battery this way, if we started with 2 molar chromium instead of 1 molar chromium, the voltmeter would read 1.13 volts and not 1.14 volts, okay? So E is less than E naught, okay? Now, you don't have to calculate it. Let's understand how the Nernst equation works and use our Q value, okay? So the natural log of a number greater than 1 is a positive number. And RT/NF, RT over NF will always be positive. And so a positive times a positive, okay, a positive times a positive is a positive number. So this potential will be less than the standard when Q is greater than 1. All right, does that make sense? Now, when Q is equal to 1, the natural log of 1 is 0. So then it would be E naught minus 0. And so cell potential, the new standard cell potential would be equal to the standard cell potential. Okay, does that make sense? And then if Q is less than 1, you get a negative number when you take the natural log of a negative number. If I take a number less than 1. So if I take the natural log of a number less than 1, okay, then I get a negative number. And then we're subtracting a negative number. So we're really adding, right? So here's the deal. You don't have to write the whole equation down. You could just say Q is greater than 1, the cell potential is less than the standard. If Q came out to be equal to 1, then the potential is equal to the standard. And if Q was less than 1, then you know the potential is greater than the standard. And you could just use that. You could just use this argument right down here. You could say, oh, Q's less than 1, so the new potential is going to be greater than the standard cell potential. Or in this case, Q was greater than 1, so the new potential is less than the standard cell potential. All right, if that makes sense, okay? So the last thing you could do, instead of, if you don't, because you still kind of have to have a knowledge of the Nernst equation. You can memorize if Q is less than 1, then this, if Q is equal to 1, then this, if Q is greater than 1, then that. You can memorize it to answer this particular question when it comes up on the AP exam. But, you know, it might not come up on the AP exam, and so, like, why am I wasting time memorizing that? Okay, so yeah, I mean, memorize the Nernst equation just in case you need to use it, but we can always use Le Chatelet's principle. If we go back up here, if we increase the favorability of the forward reaction, cell potential goes up. If we increase the favorability of the reverse reaction, cell potential goes down. Okay, so think about it this way. If in order for the potential to come out to be this voltage, I have to start with 1 molar silver and 1 molar chromium, right? Well, what did we do in part 1C? What did we do? We increased the concentration of chromium, so we added more product, and we kept this the same. Well, if we add more product, we're going to cause the reaction to shift to the left. That means we're increasing the favorability of the reverse reaction, which means we're decreasing the favorability of the forward reaction, so that means cell potential is going to decrease. Okay, so adding more product ion is going to cause the reaction to shift to the left, and that's going to decrease your cell potential. If we added more reactant ion, which is the silver in this case, if we did 2 molar silver instead of 2 molar chromium, then we would cause the reaction to shift to the right, and the cell potential would increase. Okay, so you can use Le Chatelet's principle in determining whether cell potential will increase, decrease, or remain the same. Okay. I think it's going to rain here, so I might have to go inside. Dagger. Okay. Yeah, it's starting to rain, so hold on. Let me run inside real quick, and then we'll do the live stream there. Okay. I'm going to pause this, and then I will come back. Okay. So can I pause? Can I pause the live stream? All right. I'm going to pause it, and then I will come back. Okay. I think that's paused. Okay. Can you get the outlet? Okay. All right. Here we go. That's fine. All right. Let's see. Plane. We're back. Back. Maybe. Okay. All right. All right, I'm back. I think I'm back online. Can anyone confirm that? Am I back? Can you hear me? Confirm in the chat if you can. Anyone confirm in the chat? Am I back? Back. Okay. Okay. Oh, I was never off. Okay, so you got a tour of the house, I guess, maybe? Okay. All right. I don't know. Okay, so let's go back. Okay, so before I go to, I saw I had some more emails, but let me answer Thomas's question here. Would, if we have equal concentrations of solution, would E be the same? Not necessarily. It's all about the Q value, right? If both solutions were 2 molar in this case, it wouldn't be the same cell potential because it would be 2 over 2 squared. All right. If they're all 1, then it really doesn't matter what your equilibrium expression is, because it would be like 1 cubed over 1, squared times 1, to the 4th power or something like that. Well, that would come out to be 1. All right. So Thomas, not necessarily. It's really if Q comes out to be 1. Okay. So, if it was 2 squared over 2 squared, if the chromium ion concentration was also squared, then it would be, 2 squared times 2 squared over 2 squared, Q would be 1, and then the cell potential would be the same. Okay. So not necessarily. Okay. So when they're all 1, the cell potential is going to be the standard cell potential. But if you have different concentrations, it's really going to the Q value. Okay, it's what you would really have to do is look at the Q value there. Okay, so hopefully that answers your question. Okay, let's see. All right, so I did get some more emails, so let me see. Okay. All right, so I'm watching this morning. Thank you for doing. Okay. Okay. Sorry. But for E on 6.1 quiz, whenever you are doing bond energy, is it always equal to delta H? Yes. Okay. So Riley, I got your email here. So just real quick, back to the 6.1. Yes, bonds broken minus bonds formed is also equal to delta H of reaction. So there's 2 equations for delta H of reaction that you should know. One's on your formula sheet, and that's using the molar heats of formation. And that's products minus reactants. So that's this equation. It's on your formula sheet, and right. But the bond energy one is when you do reactants minus products, but it's also equal to the delta H of reaction. Right. There's 2 ways to find delta H. You can use molar heats of formation to find delta H, and that's products minus reactants. Or you can do bonds broken minus bonds formed, and that would be reactants minus products. And that's also equal to the delta H of the reaction. Okay. All right. And let's see. Okay. So are there any other questions? So again, feel free to email me or ask your question in the chat. Are there any questions on either of these two quizzes? And then we can open it up to other questions as well. But let me know if you have other questions on these two quizzes. Either the electrochemistry quiz. Are you guys good with the electrostoichiometry? It's really just making sure you understand what amps are. If you see amps, you should immediately think coulombs per second, and and understanding what Faraday's constant is. And then I guess another thing that comes up kind of on the AP exam is instead of for multiple choice when you don't get the calculator, sometimes they'll just say 5 Faradays or like 0.6 Faradays. A Faraday is equal to 1 mole of electrons. So a Faraday is equal to this many coulombs, 96,485 coulombs, but that's also that's also the charge of 1 mole of electrons. So if they tell you 5 Faradays, they're saying 5 moles of electrons. So you're really just skipping to this step here. If I said 5 Faradays, then I could just say, okay, 5 moles of electrons times 1/2 would give me how many moles of copper I could produce, okay? So just in case you see that, like, what's a Faraday? 1 Faraday is equal to 1 mole of electrons. It's just a way for them, so you don't have to do all these calculations, right? But you could get something like this on the free response, okay? So are there any questions with the electro quiz or the thermo quiz? Yes, Faraday's constant, 96,485 coulombs per mole of electrons. Yep. And the symbol for current is really I. So I think on your formula sheet it tells you that that's a coulomb per second. So I think that's there. Yeah, so you want to remember that amps are coulombs per second and Faraday's constant. But Faraday's constant is on the formula sheet, okay? Yes, and it's 96,485 coulombs per mole of electrons. Okay. All right. All right. So, any other questions with these quizzes? I know there's a bit of a delay. So how about, okay, if you don't have any questions on the quizzes, for anyone who has worked on the concept check, does anyone have any questions on the concept check? No, I don't want to do that. All right, well, I'll figure that out. Okay. Any questions on the concept check? Or I guess I could just open it up to, any questions at all. Do you have any questions at all on, Unit 6 stuff or anything else that you want to go over? So I plan, what I want to do is I want to start in with Unit 7 next week, but I want you also to have a little bit more practice with the Unit 6 stuff. So, you know, what I've posted today is I'd like you to do the bridging thermoelectro and equilibrium assignment. I'll post the key on that tomorrow, but also at the same time, I posted a Unit 6 practice test. And feel free, like, you might not be meeting up with people, but, you could, FaceTime or whatever, or work with people together to do the Unit 6 practice test. I'll post the key to the practice test on Monday. I'll post the key to the bridging thermo, equilibrium, and electro worksheet. I'll post that tomorrow. My plan is to live stream Monday and Tuesday on the Unit 6 stuff, practice test, and the bridging assignment. And then on Wednesday, we'll start Unit 7, which is rates of reaction. So some familiar stuff that we've talked about before, and it's really not that big of a deal. The other thing I want to do, it really depends on, when are we coming back to school? What's the deal with that? Is I want to make sure that we at least discuss that lab that we haven't finished, that we've been putting off for a while. So we had the, remember the percent composition of copper in brass lab that we only did part 1 of. I want us to do part 2 and part 3, at least explain and talk about it. So we'll do a live stream about that as well, and some other lab techniques that we might not have gotten to yet. And just so when we get back, because I don't know how it's going to happen. We'll get more information on AP exams and stuff. But when we come back, it might just be, hey, in a week or 2, you got the AP exam, and we got to get moving. All right, so. Carly, why don't we do more OChem? Because they took it out, and really, like, organic chem is really your second year or second class in college chemistry. Like, so what AP chemistry is supposed to be is like chemistry 1, which is like your first semester chemistry class. And then from there you go to organic chemistry. I like organic chemistry. We just don't, and we touch upon it, but not as much as we should. But it's just, one of those things, we don't have a lot of time. Like organic chemistry, you could take Orgo 1, Orgo 2, you could take 2 semesters worth of it, or you could end up taking advanced organic. Like, there's so much content when it comes to organic chemistry. It really, you have to have a whole other class. And I think, like, in some states they do have organic chemistry in high school. So for like juniors who take AP Chem, there's the opportunity to take an organic chemistry class. We just don't have that in Virginia right now. Okay, so I got a couple of concept check questions, I think. So on the 6.2 concept check, when it asked to find the cell value of one of the half reactions given the total cell, if you're looking for the EOX, you have to flip the sign after calculating, right? Yeah, exactly. So Maddie, exactly. That's what you got to pay attention to. If you just subtract, the total cell potential, you subtract the E red from the total potential to give you EOX. But a lot of times the half reaction you're looking for the potential for is another reduction reaction. It's the one that you had to flip. So once you find EOX, you have to flip the sign to find E red. Exactly. That's how they try to trick you, to make sure you understand the concept, completely. So yeah, watch out for that. If you take the total potential and you subtract E red, then that gives you EOX. But if the reaction, the half reaction that they want the potential for is a reduction reaction, but you just found EOX, then you have to flip the sign. Okay, very good. Okay, so So number 8 on the concept check. Let me find that. Okay, number 8. Let's see. Is that going to allow me to go? Okay, maybe not. Is it lagging? All right, number 8. Number 8. Okay. So we got. Okay, so the electrons are flowing. Okay. Okay, so the diagram above represents the electrolytic cell in which the reaction, okay, sodium chloride yields sodium liquid and chlorine gas. Takes place in the table given above. Based on the information given, which is the following true? Okay, so first off, like understand that reaction, sodium chloride forming sodium metal and chlorine gas, that's not favorable at all. The reverse reaction is 100% favorable. And if you look at the potentials, right, it's chloride that's being reduced, or sorry, being oxidized, and it's sodium that's being reduced. So the reaction is going this way. So that means you would flip this reaction. Well, that would give you an overall negative potential. So the only way to make this reaction go the way it's going in the diagram here, Thomas, the only way to make it go is if you supply a voltage that's greater than the potential of the spontaneous reaction. So you would do 2.71, negative 2.71 plus negative 1.36. And you have to, the only way you could cause this reaction to go is if you applied a voltage that's greater than that value. So the operation of the cell generates a potential now, okay. The operation of the cell requires at least 4.07 volts to be supplied because the reaction is not thermodynamically favored. Does that make sense, Thomas? So if you look at the reaction, they're telling you the electrons are going this way. So that means this is the anode, this is the cathode. That means chloride is being oxidized and sodium's being reduced. So this right here, this is the reaction we flip. That becomes a negative. And so the overall cell potential for the reaction to go this way is a negative, and the only way you can get it to go in that direction is if you supply a voltage that's greater than that potential, okay? All right, and then, so I hope that answers your question, Thomas. And then the other, are there parts of the AP exam? Kind of, I mean, you've seen like, so the test that you've taken in the, in class, you know, I always throw in, you know, some lab data analysis questions every once in a while to do. I mean, it would be like, here's titration data, you know, here's this type of data. So you've seen those types of questions, okay? If you go back to the pre-labs that we've done, if you go down back to the pre-labs that we've done, pre-labs have, you know, mock data questions, like here's the lab data, you do the calculation. And that's the kind of questions they'll have. They might have like, you know, usually they do have a question that asks you how to make a standardized solution. And that's why we did that one lab where it's like, how do you make a standardized solution? Well, first of all, you know, you make a standardized solution in a volumetric flask. So the volume of the volumetric flask is the volume of your final solution. So, you know, it's very basic lab procedure questions. They usually don't ask you to write a procedure. And if they do, it's very basic. It's like, you know, fill the burette. Or the lab questions that they come up with are more, here's lab data, do the calculation that, you know, that we know how to do. You know, here's the lab data, here's the lab data from our calorimetry lab, what's the delta H of solution? So taking that lab data and finding the delta H of solution for, you know, an ionic compound dissolving in water. Okay, so it's all, yeah, so they will have, you know, kind of a lab-based question. One of the free response questions is going to be kind of lab-based, where, you know, it's like, okay, so here's the mass of the filter paper, here's the mass of the filter paper plus the precipitate. What's the mass of the precipitate? You know, and so you have to subtract to get the mass of just the precipitate. And that's, when it's that type of question, that's when they're kind of going to be sticklers on significant digits. So, you know, like if I subtract this mass from that mass, then I'm limited to decimal places, not significant digits, you know. And then And then the other types of lab questions they ask is the other thing that I have you guys try to think about is, when you do have error in your final, calculation in your lab, like, why was your value not equal to the true value or something? Like, what went wrong in lab? Like, so if the student did this, would their final value be greater than or equal to, or, be greater than or less than the actual, delta H of solution or something like that? So it's like, how would this error affect the final calculation in a lab situation? But again, we'll review so Unit 7 won't take that long, even if we're just doing it online. And then we're going to review, and one of the reviews is the lab techniques. And so what I would definitely do, Thomas, if you're worried about the lab technique stuff, in the visible learning document, at the very end are the, not before the appendices, but at the very end are all the lab visible learning objectives. So just, you might want to go through those and just check yourself on those and maybe freshen up on those objectives. But again, it's hard to test your lab skills on a paper pencil test, right? You're not going to do a lab. They might say, here are the materials, what's the setup? They might show you a galvanic cell setup and ask you what's wrong with it or something like that. Like, oh, there's no salt bridge, or there's no porous disc or something like that. So, yeah, they will ask lab stuff, but you want to keep it as simple as possible. Don't make it more complicated. They're going to ask you the most simple lab questions. Like, they'll give you a picture of a burette before and after, and they ask you how much volume that you added to the flask, and you just do the final reading minus the initial reading, that kind of thing. Those are the types of lab questions they ask, because that's really all you can kind of ask on a paper pencil test, if that makes sense. Okay. What other questions? Any other questions? Either on the concept check or anything else. I mean, it doesn't have to be on Unit 6. I mean, if there's other stuff you have questions on, maybe you're working on test corrections and you have questions about that, or, concerns about the AP exam and you have questions on that. Anything? The concept check, anything? Okay. Can you go over number 18 on the concept check? All right, let's see. All right, 18. Let's get there first. All right, 18 on the concept check. Let's get there. All right. When a magnesium wire is dipped into a solution of lead nitrate, a black deposit forms on the wire. Okay, so what's happening there? The lead is being plated onto the wire, right? Which of the following can be concluded from this observation? Okay, so what's happening is the lead ions are being reduced in forming lead solid on the magnesium. It's being plated right onto the magnesium wire. So this is neutral magnesium wire, solid magnesium, neutral, not an ion. So what's happening is lead 2+ is going to be being reduced, and that means magnesium is being oxidized at the same time. So magnesium 2+ is being produced. So lead 2+ is being reduced to form solid lead, and then magnesium. Hold on, my dog's barking. Hold on 1 second. All right, so lead is being reduced and magnesium is being oxidized. So the standard potential, reduction potential for lead 2+ is greater than magnesium 2+. Magnesium solid is less easily oxidized. No, because magnesium is being oxidized and lead is being reduced. An external source of potential must be supplied. The only way, well, it said when you dipped it in, this happened, and so the reaction happened without an external source. But really, the only way to know that one is if you were given standard cell potentials. So the magnesium wire will be the cathode. No, so magnesium is being oxidized, so the magnesium wire would be the anode, so D is not right, and lead solid can spontaneously displace magnesium 2 plus. That's like, that answer looks kind of good, but it's not, the lead solid isn't displacing magnesium 2 plus. It's lead ions forming lead solid is replacing solid magnesium and kicking them into the solution. They're not displacing in the solution. So it comes back to A. So it makes sense. Lead is being reduced and magnesium is being oxidized. So that means lead's reduction potential is greater than magnesium's reduction potential because lead gets reduced and then magnesium ends up being oxidized. Okay. All right. What else? Anything else? Any other questions? Is there anything else you'd like me to, talk about? Other subjects or anything? And like other, past units or anything like that? Okay, so how to read a burette. Let me see if I can maybe like pull up a picture or something. Let's see, it was on which test? Was that Unit 2? Let's see, did we have Unit 2? Unit 2 test, right? Unit 2. Is that the one with the burette reading? Let's see. Was it Unit 1? Yeah, okay, here we go. Unit 2 had a burette reading. Okay, so the key, for burettes, just understand two things. If you're using a regular, it's usually a 50 milliliter burette, you're allowed to go to 2 decimal places because each tick mark on the burette represents 0.1 milliliters, right? So like right here, this is 3 milliliters, that's 4 milliliters, and then you got 10, things in between. So each tick mark represents 0.1, a tenth of a milliliter. So your measurement is allowed to go to the hundredths place. You're allowed an estimated digit, okay? So if you remember all the way back from Unit 1 in regular chemistry or honors chemistry, that's what we learned. You have to take that estimated digit. You have to know what the glassware gives you in terms of precision. In this case, it gives us the tenths place, and you're allowed an estimated digit, in this case, the hundredths place. So whenever you're taking a burette reading, make sure you go to the hundredths place, okay? And so what you do is you get a value for the initial burette reading. So in this case, the initial burette reading, and remember, it counts kind of backwards. So this is 3, this would be 3.1, 3.2, 3.3, and then 3.4. So to me, it looks like it's in between 3.3 and 3.4. So you could estimate, 3.35. Okay, so maybe 3.35, or if you thought it was right there, right on the line, you could say 3.40. Okay, but just don't say 3.4 or don't say 3.3. You're allowed that estimated digit. So I would say 3.35. Okay, but again, there is some leeway. So this is an actual this question. To go back to Thomas's question, this is an actual question from a past AP exam. This was the question, and it was actually even less complicated than this entire question, but it started with this. So this was one of the questions on a past AP exam. And so, if you said 3.36, that's acceptable. 3.39, that's acceptable, right? So I would say 3.35 for me, and then I would go down here, And then I go to my final reading. So that's 29, that's 30. So we're 29 point something. So 29.1, 29.2, 3, 4, 5. So we're in between 5 and 6. And it looks kind of halfway to me. So then I would say 29.55. So I would do 29.55 would be my final reading. And then to get the value of how much you added, it's just the final minus the initial. So it would just be 29.55 milliliters minus 3.35 milliliters. And my final answer should go to 2 decimal places, because when you subtract measurements, you are allowed the decimal places. And so it would be 29.55 minus 23.35. And I would go to the hundredths place for my final answer. And that's how you read a burette. Okay. And you just do final minus initial. Now, if you start at 0.00, if that's your initial reading of the burette, then the final reading is how much you've added, because it's final minus initial, and in this case it would be final minus 0.00. Okay. All right. So I hope that helps. Let's go back and see if there's any other questions. Okay. Any other questions? Okay. So that was a good question, how to read a burette. Okay. And again, we're going to have some time here. We don't have to do everything all at once. Right now, we really should be focusing on Unit 6, but I'm happy to answer other questions right now. We will do kind of a review as we go. Like, we will review lab techniques. We will review other units. Okay, we'll go through all that stuff. Hopefully you have all your chemistry stuff, and hopefully you have most of your unit tests back, because what we could do is, as we prepare for the AP exam, we could go through past unit tests, and then maybe school might not start back up, but maybe they'll start opening up things, and maybe we can meet at the library. I have all the practice tests, so maybe at some point we'll be able to meet somewhere like the library or something, and you could take practice tests or something. But we'll figure it out. Don't worry too much. Just try to stay on top of it. All right. When we are reading the burette for a titration, when none of the titrant has been added, is it 0.00? Okay, so when you're doing a titration, and you haven't added any titrant, if the where is that? If I start at 0.00, then yeah, that's my initial reading. It's not 50 milliliters, right? So the whole purpose of a burette is to measure how much of a solution you've added to your flask that you're adding it to, right? So like I have my burette, I'm opening and closing the stopcock here to go down and let this solution go into whatever other solution I'm mixing it with, right? That's the whole purpose. So like the measurement of a burette it's not like a graduated cylinder where you're just trying to figure out how much liquid you have. You're just trying to figure out how much of this solution did I add to the flask. So before you start your titration, you've added 0.00 milliliters to the flask. Now that might not be the initial reading. Like let's say we started my titration, but this is where I started. This is what I started in my burette. Then my initial reading would be 3.35 milliliters. And if I haven't added anything, then my final reading is 3.35 milliliters. And then final minus initial would end up being 0.00 milliliters added, right? The whole point of a burette is the measurements are to figure out how much of this solution did you add to your flask that's down here. So that's why it's the final minus the initial. Okay, does that make sense? It's not about how much can fit in the burette. Yeah, it's important to know how many milliliters you can fit in your burette. Usually it's 50 if it's a 50 milliliter burette, because if you know your titration or whatever you're doing is going to require more than 50, then a burette's not a good thing to use, right? And I think that was one of the questions like down here, like if you use a way less concentrated solution, why wouldn't this same procedure be feasible? And it's because you would need 430 milliliters of the solution in your burette, but your burette only holds 50 milliliters. All right. Does that make sense? I hope that answers your question, Charles. Okay. All right. Next question. Okay, so when they say something has a dipole moment, that's just telling you it's polar. If they say zero dipole moment, that's telling you it's nonpolar. So a molecule has zero dipole moment if it is nonpolar. Zero dipole moment means a nonpolar molecule. So that means if something experiences a zero dipole moment, it means it's symmetrical, it's nonpolar. And if a molecule has a dipole moment, then that means it's polar. Okay, and what the dipole moment is, let's see. Like dipole moment is just another way of saying polar. So if a molecule has a dipole moment, we're saying it's polar. It's not symmetrical. It's asymmetrical. And if a molecule has zero dipole moment, then that means it's symmetrical. It's nonpolar. Like all the let's see, do I have it here? I might not have it here. Nomenclature, IMS. Oh, come on. So remember, here is a polar molecule, and this is the way to show, one side. But remember the other way to show a dipole moment, or the polarity within a bond and within a molecule, like, so this is a bond, but it's also a molecule because it's a diatomic molecule, would be to draw like a plus sign above this and then extend an arrow to the negative one. So it would be like from positive to negative. And that's showing the dipole moment within the molecule. As you go from this side of the molecule to that side of the molecule, it's becoming less positive and more negative. And that's what they mean by dipole moment. But again, if you see the word dipole moment, just replace it with the word polar. Why does this molecule have a dipole moment? The question is asking, why is this molecule polar? It's because it's asymmetrical. And if it says, why does it have zero dipole moment? It's like, why is it nonpolar? Well, because it's symmetrical, all right? So that's what dipole moment means, okay? All right. All right, other question? Okay, so this is what I'm planning. So I don't know, like, and can you guys, here's a question. After I live stream, they go into my channel. Can you guys access those in the channel? Like, can you watch them later? Do I have to make those public, I guess? I don't know. Like if you miss a live stream, I guess I could post them on the Google Classroom. I got to figure that out. I don't really know how YouTube works that well. Do you have access to go back and look at the live stream from Wednesday? I know it's on there. It's on my channel, but I don't know if I have to do anything to make that like accessible to anybody. Maybe you could answer that question in the chat. But anyway, if you know the answer. But anyway, yeah, I wanna live stream Monday and Tuesday, and then Wednesday. I don't know, like Maddie. I don't want to overwhelm you with stuff, and I know you probably have other things going on with other classes and that kind of thing. So I want you to have. Okay, so you can see them on the channel. Okay, good. So if you follow the link, you can still see them. So yeah, that's the plan for you guys. Like for honors chemistry, I'm really only doing it every other day, really depending on what we're covering. But for you guys, like starting next week, I'm probably going to do one Monday for the bridging assignment that I gave you, And then I want to do one Tuesday to go over the practice test that I assigned you. And then I'd like to do Wednesday as well so we can start to get into Unit 7. And then we would then I'd probably, after we do Unit 7, the intro to Unit 7, I'll give you some practice problems, and then I won't live stream until Friday. So yeah, next week's probably Monday, Tuesday, Wednesday, and then Friday would be the live stream plan. Starting around 9:45 each time. But yeah, that would be the plan. Okay. All right, so if we don't get back to school when we get graded assignments is how we are going to have the class. Yeah, I guess this is how we're going to have the class. I don't know. I have to see. So if we don't get back to school and we end up having graded assignments, I guess this is how we'll have the class. Does this work for you? Like, I mean, I could have a PowerPoint going and be talking, and I could get my mug. I don't need to be in this box here. You guys don't need to see me. And I could just do voiceover and stuff like that. But yeah, this is how I would plan. This is how I'm thinking. But I think the county might offer us more materials once it gets there. Like, I think, I don't want to say this out loud. I think live streaming is okay, but next, as long as we're like not really covering new content, but they really don't want us to cover new content, even though I think we're still going to, just because it can't hurt. And I'll just cover it again if I'm told to. So this is how we'll have class, and then how I'll assign grades. I don't know. We'll cross that bridge when we get there, and I get more instruction from the county. They haven't really told us much. We know what Mr. Mukai sends out is what we know. To everyone, to all of you, that's what we know as teachers. So right now, non-graded assignments can be sent out, and technically not supposed to be doing new material. But we're kind of at that point of the year where it's, I think I can spin it in a way that it's really not new material. Like, kinetics is all about collision theory, and we've talked collision theory before. Like, how does a reaction happen? And we do that weird thing with our hands. So we've talked about it, so it's not new technically. So I think I can get away with that. But I think that's the way class will be for a while here. And then, I'm really only getting emails during the live streams. Feel free to email me off the live stream. I can get back to you and answer questions, as well. All right. Let's see. How do we make a standardized solution, and what would be questions related to it? It's like, how would you make a standardized solution? Go back, Thomas, go back and look at your lab on how you made a standardized solution, right? Remember the Boom Baby PowerPoint? That's the one to go back and review. How do you make a standardized solution? You figure out, you have to do M1V1 equals M2V2, and you're trying to figure out M initial. Your M final is your V, you have to figure out your V initial. Your V final is the volume of your volumetric flask. So if they give you a 100 milliliter volumetric flask, then that's your V2. If they give you a 250 milliliter volumetric flask, then that's your V2. And your whole idea is you do M1V1 equals M2V2 to figure out V1, and that would be the volume of the standardized solution that you're trying to dilute. So let's say you have a 1 molar solution of hydrochloric acid, but you need to make a 0.5 molar solution of hydrochloric acid. Well, really, you just need to cut it in half. But what you would do is okay, so here's the volume of my volumetric flask, 100 milliliters. That would be my V2, and my M2 is what my final molarity I want it to be, so 0.5 molar. And then my M1 is the stock solution I have available to me, 1 molar. and then I would solve for V1, and V1 would tell me how much of the stock solution I add to the volumetric flask, and then I fill it up to the line with distilled water to make that final volume. The other like that's if you have a stock solution. So we did that one, right? We did that lab, and kind of like our buffer lab, that's kind of the other way to do it, right? When we made the buffer, you made a standardized solution of either sodium acetate or ammonium chloride, depending on what salt you used. And so you had to figure out how many moles of that you needed in the volume of the volumetric flask. And then you had to go from moles to grams, and that's how much you measured out. And then you would put that many grams in the volumetric flask, fill it up to the line with distilled water. In the buffer lab, we filled it up to the line in with the acid or base that we had available. But regardless, you fill it up to the line with the correct volume, and that's how you make to the line to get the correct volume you need, right? Does that make sense? Okay. Just so you know, there is about a 15-second delay from when... Okay, yeah, I know there's a delay, so I know it's a little awkward. But whatever, you can't really do it. Can't really worry about it. All right, let's see. I got another question. Okay, sounds good. And we still have time to retake quizzes before the final exam? I don't know. I don't know if we're gonna have time. I don't know when we're gonna get back to school, and I don't know if they're gonna delay, if they're gonna postpone AP exams. Because if they don't postpone AP exams, I'm not really gonna postpone the final exam. Maybe there'll be a chance to, maybe what we'll do is just make sure you have your corrections done, So that's, in the meantime, if you need something to do, if there were quizzes that you wanted to retake, we might not have time for you to retake them all. So in the meantime, do corrections, do very good corrections on the quizzes that you want to retake, and maybe I can collect those and give half your points back or something like that, or give half the points back to some, and then maybe you'll be able to have time to retake the others. Or what we could do is extend it maybe like a couple weeks that you could take it after the AP exam. So I'd prefer you to retake them before the final exam and before the AP exam, but then maybe maybe I'll leave it open for like a week after that, and you can retake your quizzes. Because, after the exams, we're not going to be doing that much in class. I'll be allowing you to prepare for your other exams that you might have, and other things that you might need to do. So, maybe the next, like the 2 class periods after the AP exam, I'll leave open for kids to take retakes on quizzes that they needed to retake. But yeah, I have no idea. I have no idea what the plan's going to be until I know when we're going to get back to school and when the AP exam is going to be. Is the AP exam still going to be May 7th? And if the AP exam is still May 7th, like, are we going to get back to school right before then? So we might not even have time to take the final exam before the AP exam? I don't know. So, we might be in a position where you have to take the AP exam before the final exam, and that would kind of stink. But then that means you still have to take your final exam, and we would have time to review for the final exam after the AP exam, and then you could, retake quizzes during that time. It wouldn't help you with your actual AP exam score, but it would help you with the final exam, which is, the important exam for your overall grade in the course. All right. Okay. Any other questions? Hopefully that answered your question, Eden. But I don't know. But again, I don't know. But I'm not going to be kind of like a tyrant about it. You know what I mean? Like, I understand this is kind of a unique situation, and I know a lot of people are kind of they're in the place where they want to improve their grade, and now all of a sudden they're not going to have really that chance to do it. But we'll figure out something. You know what I mean? We'll I won't just say, oh, nope, time's up. Sorry, grade is what it is. We'll figure something out. You know what I mean? Like I'm going to be flexible depending on the situation. Does that make sense? So that's not something to stress over right now, because we really don't know until we get told what the actual plan is for us to return back to the classroom. Okay. Any other questions? Anything else? I got my amiibos here. Anyone like Zelda? Been playing a little Zelda. Got to kill some time. Questions? Concerns? I didn't say anything. I think we're good. All right, so in the meantime, do the bridging assignment and go ahead and start looking at that practice test. The plan will be I'll live stream again on Monday, and we'll go over the bridging assignment. I'm going to post the key to that tomorrow, so you'll have some time Saturday and Sunday to go over. Breath of the Wild. My two favorites are Ocarina of Time and Breath of the Wild now. When I was a junior in high school is when Ocarina of Time came out, and so I really like that one. And then I got the Switch as soon as possible, and been playing Breath of the Wild. Love it. But anyway, so I got all my amiibos here, got all my Breath of the Wild amiibos. To give me some, extra bonus stuff. But anyway, so the plan will be live stream Monday. We'll go over the bridging assignment if you have any questions on that, and then we will also, you got the weekend. Come up with some other questions too, okay? But I'm going to wait and answer questions on the practice test until Tuesday. So you have bridging assignment and you have the practice test, but you don't ask questions about the practice test until Tuesday. That'll be Tuesday's live stream. Will be the practice test. I'll post the key on Monday for the practice test, and then we will discuss it on Tuesday. And so, if the bridging assignment's not that difficult, you're just saying, it increases, it decreases, it's this, it's that, it's endothermic, it's exothermic. So it's not that big of a deal. So you might not have that many questions about the bridging assignment on Monday, but feel free to come up with other questions. Like if you're working on quiz corrections or test corrections, or if you're going back and reviewing all the VLOs, from the past units, just because, you're still responsible for those, maybe go back and review all those, or, Thomas, go in and look at the lab VLOs at the end of the VLO thing, and just, because if you're concerned about the lab questions, but again, we'll do some review too as we move forward, like into next week and the week after. I might just do a live stream where I go over all the different lab questions that have been asked in the past, so you're kind of prepared for that kind of thing. Okay, so we'll meet again on Monday. I hope you have a good weekend, and I'll be posting the key to the bridging assignment tomorrow and the practice test on Monday. All right. So thanks for joining me, and smash that like button, and don't play too many video games. All right. Have a good one.